Okay, so to derive the laws of refraction using Huygens principle, we take two mediums, 1 and 2, separated by the line OO dash. Now let the velocity of light in medium 1 be v1 and in medium 2 be v2, and their refractive index with respect to vacuum be n1 and n2 respectively. Now medium 1 is rarer than medium 2, let's assume that. Now let a plane wavefront PQ traveling in the direction P dash P in the medium 1 be incident at the interface, and the wavefront makes an angle I with the interface, and accordingly by geometry the angle P dash Pn here is also I. Now as per Huygens principle, we will have secondary spherical wavelets travel out from point P in medium 2 with a velocity v2. So if the wavefront takes a time t to travel from Q to R in medium 1, in the same time the secondary spherical wavelet from point P moves out to a radius equal to v2 into t. So to get the shape of the refracted wavefront, we draw a tangent to this sphere from the point R touching the sphere at D. Then this line dr is the refracted wavefront at time t. Just a pointer, all the rays from the wavefront PQ after time t will have secondary disturbances touching the line dr as tangent, since dr is the refracted wavefront and this is as per Huygens law. So now if we mark angle dpn dash as r, then by geometry angle prd is also r. So in triangles PQR and PRD, sin I is equal to QR by PR and sin R is equal to PD upon PR. And since QR is equal to V1T and PD is equal to V2T, we get sin I divided by sin R is equal to V1 by V2. Also, we know that the refractive index N1 is equal to C upon V1 and N2 is equal to C upon V2. And that implies that V1 by V2 is equal to N2 by N1. So putting it in this equation, we get sin I by sin R is equal to N2 upon N1, implying N1 sin I is equal to N2 sin R, which is the Snell's law. And this is the law of refraction, which we had started to prove in this question.